morning. I'm going to talk about databases today. Glad everybody could make it. Hope you can hear this and then it goes well. So your assignment for this week is to start on Access. Access is a database, and so the presentation here is just about databasing, and then we'll take a look at an Access file so that you have somewhat of an idea of what you're heading into. So why would we study databases? Well, we're all in, I don't know, how many would you guess? 100, couple hundred? You have a state license, you're in a database. You have insurance, you're in a database. You have a cell phone, you're in a database. You're in multiple databases there. You're not only in a database because you have a cell phone, but you're in a database for all your friends. You go to the doctor's, database. Ever been to the pharmacy, had to have a prescription filled? It's a database. You have a rewards card, database. Bank account, I guess you get the idea. Anyway, you're in a ton of databases. So why learn about them? Because they're here to stay, and you might as well embrace it. I will say that this lab, all we're going to really do, you manage databases already. If you have a cell phone, if you have an email account, you already manage databases. So what you're going to do today or in the next few labs, this is our last application to learn, so the semester is winding down. What we're going to do is just pull the curtain back a little bit so that you can see behind the scenes how these databases are managed. So a database is nothing more than a collection of data organized in some manner to allow us to do stuff like query it, ask it questions, look for patterns or trends, retrieve information. It's just this collective data that we try to organize, kind of like your address book on your cell phone. I can get a little bit out of hand, but still just the same. And we can create forms and generate reports with this data. So typically with the database, what we're doing is collecting historical data as it takes place. So you go to the library and check out a book. That's a database where they're capturing that transaction for future reference. I talk about what we can do in these databases. We can track contacts, we can make schedules, we can track our possessions or make databases of things that we collect. My mother-in-law collects cookie cutters, so we could create a database of all her cookie cutters and keep valuable information like how much she paid for it, how many of them she has, maybe what the condition is that they're in. So if we were ever to want to resell those, we would have a list of everything that was going on. We can process orders. So when you go to the grocery store, that's a database. It's an interesting database because what happens when you go to the store is that you'll buy something and they'll scan it. And in the background, what happens is it reduces their inventory by the number of items that you purchased of that type. So let's say you bought a candy bar. So it would do is it would reduce the inventory for that candy bar by 1. And sometimes what will happen in grocery stores or retail environments is that in the background, they'll set a minimum and a maximum inventory level. And we call that a min-max level. When it hits a minimum level, it can automatically trigger a purchase order for that item without any human interaction. So we can do a lot of things with databases. And now we're actually moving into a period in time where we're talking about big data. One of my questions to you would be, is Facebook a database? Is Amazon a database? They are. So how do we talk to these databases? We do it in something called SQL, structured query language. You won't really work in that. You won't really deal with creating queries and things like that. But just so you know, we call it SQL or structured query language or SQL. So because of databases, we're not in a standalone environment anymore where we just work on our own computers independently from the rest of the world. Now we work on servers. So we maintain these databases on servers, and that creates a little bit of a challenge because if we're working on a server and all of us are working in the same database, how do we preserve the integrity or the accuracy of that information? We need to preserve the accuracy of that. And you and I are making decisions and planning based on the information that we capture there. So think about it when you roll in spring semester. We want to make sure that that information is accurate. It's a database, you search it looking for the classes to take. And if it weren't accurate, what kind of decision would you make? Probably not a very good one. You didn't have accurate information. So accuracy, timeliness, things like that. But because we keep it on a server so that all of us can access it at the same time, we have to have a means to control the access. And we can control the access to the smallest unit level of unit level. So we'll talk about that in a minute. It can be exported into spreadsheets or other databases. You can import it into other databases. You can create charts with it. Once you're in Excel, you can do all kinds of things that you learned about in Excel. So it's a very powerful piece of software. But just know that Access is a database management software, where Word and Excel are just data management. So you can do stuff with data, but you can't maintain the database itself. So databases came about in about 1980. So they're kind of not embryonic, but they're still in their infancy because they're evolving. We've now kind of evolved to this thing called big data. And the problem with big data is that it's constantly moving. There's a high volume, it's constantly moving, and it doesn't all look the same. But corporate America and our country are using these big data sets to make decisions about our country or how a corporation might work. So anyway, E.F. Hobbs created this database idea back in 1980. What we're doing on databases, as I said earlier, is collecting historical information. And then what we do is we do something called data mining, where we talk to the database, we query the database, we analyze the data that we're capturing, typically to try to find previously unknown relationships or statistics or trends or patterns so that we can kind of predict the future. But there are things called anomalies. And what that means is that although we've captured this data, there may be other things external to the data itself that impacted it. So for example, if you were a purchasing agent at a grocery store and you were doing purchasing for the year 2000, from 1999 to 2000, we had something called Y2K, where we thought that the planes were going to fall out of the sky, our financial structure in the world, our global financial structure would collapse. There were a lot of issues with that. And so if you were a purchasing agent and it was on New Year's Eve, because they thought when databases rolled over from 1999 to 2000, we were using 2-character field names at that time, it would roll from 99 to double lot zeros, meaning everything would roll back in time, or that was the thought process. We were still new to all this. So if you were a purchasing agent at the grocery store in 2000, then you might look back and go, wow, we ran out of all these perishable goods, water, canned goods, things like that. And so what you would think is possibly, you know what, I'm going to order double what we ordered last year because we ran short. Well, the anomaly is that it's not Y2K, and that was something that impacted probably the what inventory looked like rolling from 99 to 2000. We also build something called executive dashboards, online analytical processing machines. So these are what executives use. And when we look at an executive dashboard, we bring together many databases so that you can make informed decisions. So for example, if you're the chancellor for Warren County College, you might look at how many incoming freshmen there You might look at how many high school graduates there are in our area. You might look at degree programs, how many are accepted and how many graduate. You might look at how many resources go towards the different programs or marketing the programs to be able to make some decisions about the future, how to change things to improve them, maybe what your competitors are doing to attract students. Maybe we should be looking at that. Probably in that executive dashboard, they're also looking at news reports on not only Tarrant County College and what's being said about us, but some of our biggest competitors as well. So that would be something you might see in an executive dashboard. When we talk about big data, and that's where we're moving, where we making trillions of records in databases. The problem with big data is it's a little more, it has such a plethora of information in it, such a high volume of information that it's really hard to analyze. So they're actually offering degrees in this now because people don't understand how to interact with it. We have special, it's called NoSQL, which is not a structured query language, but it is the language we use to analyze this big data. There are add-ons in Excel for analyzing big data because big data has a couple of problems. Constantly changing. So just for an example, think about the GPS information we capture off your phone. We're moving targets, so we're hard to hit. So we're capturing that data. We're looking where people are driving. Maybe they're using that at the city to try to look at what roads or bridges might need to be repaired. So it's constantly changing. The volume, the sheer size or the amount of data that we're trying to analyze is very large. The varieties, so not all databases are really nicely structured in a cute little package. We have things like Facebook, where you are capturing data and whoever has a Facebook page, all of our pages may not look the same. Some may have videos, some may just be chats, some may just be pictures. How do we analyze that? Look at the videos that come up on YouTube just in an hour, okay? How do you analyze that to figure out what it is people are doing or interested in? And then we have something called data warehouses. And a data warehouse is where we bring together more than one database. So for example, Amazon would be a prime example of a data warehouse where they bring a bunch of different databases together. So when you're looking for something like mountain bikes, it doesn't just search one database, it searches multiple databases to bring back results that match the criteria of the things you're looking for. I want to go back to big data for 1 second and talk about the issue of privacy. There's a concern with privacy when we talk about big data, primarily because our data, we have a lot of things out there. I mean, think about your insurance. Think about coming to Tarrant County College. You're in a database. We have all your personal information. We know where you live. We have your social security number. We have your birthday, phone number. We have all of that information on this side of what we call a firewall to protect that information or your data. So your data is only as secure as the weakest link in our security department. Now, I will say at Tarrant County College, we're very aggressive and assertive about our data security, and so we do a really good job with that. But just be aware that in big data, they're the holy grail, and we're the holy grail in that big data because they want our personal information. So, big data. When we talk about data models, we're talking about the underlying structure of a database. Here are the models: flat, hierarchical, networked, relational, dimensional, object, and object relational databases. Our focus for our discussion for access will be this relational database. We're unstructured. And what we're talking about are records, and just kind of hold these terms in your head for a minute. Our records is each record in the table the same or in the database the same. So a structured database, think about you at Tarrant County College. We have a huge database, and in that database we have a table probably called students. In that table, when you come to school here, you filled out an application. Every student that comes to school at Tarrant County College fills out the same application with the same information. That would be an example of a structured data model where every record is the same. Unstructured model would be something like Facebook, where not everybody's Facebook page is the same. So we have structured and we have unstructured data models. But again, our focus is going to be this relational database management system, the RDBMS, okay? Just a collection of tables where we can organize things kind of like in Excel, columns and rows, but now we have different terminology. We'll go over that in a minute. Where a column intersects a row, we call that a field of information, and a row of information is considered a record. In Excel, we had worksheets. In relational databases, we're going to be working with something called tables. And so we'll go into a little more detail about that in a minute. And then this just talks about big data again. Okay, so really, I'll go into this in a little more detail in the next, I think it's the next slide. What we're going to be talking about are fields of information. Fields of information are the smallest unit of information that we will collect, okay? Meaningful information, smallest unit of meaningful information that we'll collect. Every field has to be assigned a unique name. A collection of a group of fields is called a record, and a group of records are called tables. We query those tables to extract information based on certain criteria, okay? Like I might go to Tarrant County College and I want to know the number of students for retention purposes. I want to look at data on the number of students we had in spring last year that will enroll, or let's say fall last year, who enrolled in fall this year. If you were here last fall, did you come back this fall? We study that information. We query that information out of the 50,000 unique students that attend Tarrant County College every semester. About what I might want to do is extract the information about students who were freshmen in fall of 2019 who enrolled in fall of 20. And so I can query that and extract just that information. I can generate reports, and that's what my output would be from this query. And then I can also create something called forms. And forms are things that we use to enter data. And we'll take a look at that in a second. We create these forms to make it more user-friendly for you and me. Otherwise, we'd be entering information across a row, kind of like you do in Excel. So here it is. These are the terms. These are the things we need to come to grips with. Field, record, table, relationships, or what we call diagrams, the ERD. So these are the terms that you're going to come to grips with. So the field is the smallest unit of information. If I told you my name was Joan Shriver, what is the smallest unit of meaningful information in that Joan Shriver? Would it be the letter J, or would it be my first name, Joan? So being meaningful information, it would be my first name, Joan. So our fields can be fixed in length or variable in length. What I mean by that is that for each record in our table, if it's fixed length, the database will reserve the same amount of space for every record, whether we use it or not. In a variable length field, it will only take what it needs. So let's just take a look at this one right here. This is a record, okay? And this field named album. The album is the Beatles 1962 to 1966. So this right here is probably a variable field. No, it's probably a fixed length, but maybe it's like 25 characters. But it's always going to take 25 characters, whether that album title takes all 25 or not. If it were a variable length, then it would only take what it needs to display that data. So fixed length means every record's going to have the same amount of space reserved for that field or saved, whether it's used or not. Where in a variable length field, it's going to take only what it needs. And if you don't enter any data, it won't reserve any space. Again, every field has to have a name, and that name has to be unique. Now, a group of fields is called a record. We have two kinds of records. We have a record type. We have a record occurrence. A record type is like a template you learned about in Word, predefined kind of form that you filled out. So when we talk about a record type is how we define our tables. So the thing about databases is that we can define at the field level what kind of data that field can contain. So when we just define a record, it's called a record type, and really what we're doing is designing a table. A record occurrence then would be any record that has data. This right here would be an example of a record occurrence because it has data. Here are my field names, and here's my data. The entity relationship diagram, or something called cardinality, is the relationships between different table or record types, which means tables, okay? The ERD is the relationship between different record types. We can have a one-to-one, one-to-many, and many-to-many. So what this means is that we can have when it's a one-to-one, we can have one record in one table related to one record in another table. A one-to-many means we can have one record in one table related to many records in another. And many-to-many means we can have many records in one table related to many records in another table. The way you depict that is a crossbar would be a single one-to-one. This would be a one relationship. Or when you have a crow's foot, that's the multiple relationship, or many. So let's think about a one-to-many relationship for a second. You're a student at Tarrant County College. We probably have a database. Well, I know we have a database that probably has, let's say, 3 tables in it. We'll have a table of students, we'll have a table of fall 20 courses, and we'll have maybe grades. And so you as a student at Tarrant County College, in my student table, I want only one record for every one of you. I don't want to have 2 or 3 records that represent you, right? So we give you a student ID so that that is the unique identifier for you, because just let's face it, we have a lot of students that have the first name. We have a lot of students potentially that have the same last name. We actually even have students that have the same first name and last name. Social Security number is unique, but we're not allowed to use Social Security number to identify a person. So we give you a student ID. All right, so in my student table, I have one record for every one of you. And I'm going to make, so that's my one table. My second table will be my fall 20 courses. Well, you might be taking more than one course this semester. So the relationship between my students and my fall 20 course table would be a one-to-many. I have one of you in my student record, but I might have you many times in my fall 20 course table, right? One record of you in my student table related to possibly more than one record in the fall course table. So one-to-many. That's how we create the relationships. And we link it on fields. So for example, we would use your student ID to link the student table to the fall 20 courses table. So because we use databases on servers and in multi-user environments, we have to have someone in charge of controlling access, preserving the integrity of the data, preventing changing information that shouldn't be changed. We have to have a backup plan, especially now that we're talking about big data. So we've got to have some place, especially with the threat of ransomware and hackers and things like that. So we need to have backup somewhere, typically off of our facility, where we maintain a copy of everything that we're doing. Think about 9/11 when the Twin Towers came down. Those were all, majority of those were financial institutions. Luckily, they had backups off the premises. And so this database administrator, if you're intrigued by Access at all, this database administrator is a fabulous job. You manage the databases. You can control access to the field level of what people can manipulate. So I'm an instructor. I can only manipulate your attendance and your grades. I can see your social security number, I can see your email, I can see where you live, phone number, birthday, I can see all of that, but I can only view it. I can't modify it. So the administrator also has to ensure integrity, right? Because corporate America, like Tarrant County College, we're going to make decisions based on the accuracy of that information provided. So, for example, we have a minimum requirement of 15 students to be enrolled, or we used to. 15 students had to be enrolled in a course for a course to make it. So if we didn't keep accurate information at the course level about what kind of decisions would we about canceling these classes? Probably not good ones. We have to prevent users from inadvertently changing or deleting important data. And we have to make sure that the group of people or the person that's responsible for maintaining for things, for example, like your mailing address, that's the only person who can gain access, that I can't gain access. Because let's say you tell me one thing and you present something to the registrar's office updates it, and then you tell me something and it was before you submitted the paperwork, I might update your record. Now we have erroneous information. This database administrator has to make sure that the software is always up to date, and it has to have a backup plan. Okay? And then we have to establish security procedures. So this will prevent, hopefully, make it a little more challenging for hackers to come in and access the information. So this is what it looks like. This is client software. So we have a database over here and we're clients, so we're talking directly to this database. The only problem with this is if we all want to access the same piece of information at the same time, there has to be some type of intermediary that will control it to control our access to the fields of information. So let's say this guy here, this top guy calls a record out, requests a record, and it comes to his system. And these two people want to have the same record. Well, if it goes to this guy here, we have to have something, some type of policy implemented so that these two can still view the record, it just can't modify it. And so this is kind of a challenging environment. So we put things out in a distributed system and we put it on a server. But if you work in a standalone environment, that's not bad because it's actually going to be on your system. But in this case, what we use database server software to talk to the database. So when we all send in a request, it goes to the server software that talks to the database, brings back that information, and controls the access for these users. So if this guy in the middle got it up there first, he may be able to gain access to being able to edit those records where these two other folks can't do that. So this intermediary software will take care of that. Something to think about, and this is when you're working on a server, but something to think about, because when we're out on the World Wide Web, we're actually trying to talk to databases. But we, in our browsers, use something called HTML, hypertext markup language. So we have to send it through a server that will take that HTML and send it and convert it into SQL. Then once we retrieve the records from our database, we have to send it back through this server that converts it and talks convert it into HTML. So we're talking SQL to the database, but you and I, our browsers only understand HTML. Our websites are static, they're dynamic, they have and can have XML. So static means they never change. Go to a website, it's always the same. Dynamic means that it changes based on maybe what it sees in the cookies on your system. So it's responding to your recent searches. And then the XML is the piece where we can interact with it. Like you go to Amazon and you want to search on mountain bikes. And so you put in mountain bikes and it takes your entry in HTML, converts it into SQL to send it to the database so that it can bring back the results for you. So, and then this is just a diagram kind of showing you, you're talking HTML, you go to a server-side system, it talks to converts it into SQL, talks to the database, brings it back, converts it into HTML because your browser can only display HTML. SQL, structured query language, this is how we talk to our databases, okay? The overall language, SQL. We have specific commands, and you're not really going to get into programming, but I want you to understand, and I'll show you where you can see it. We can talk to these databases. That's why we create them and develop them. We've got 6 commands typically that we can use. We can create, we can delete, we can insert, we can select, we can update, and a join is a select based on 2 or more tables. We can put operators in, and, ors, or not. The Boolean operators can be used inside SQL. And we have to provide some type of parameter so the database knows what to bring back to us, or what to do, or how to interact with the base. So when we create, we're creating from scratch. We can create databases, we can create tables, queries, forms, and records, or reports. And so the create command. We have the delete command, and that's where we get rid of records. We remove them, we delete them from our tables. We have an insert command, which is just adding a record. So what I want to show you, well, and so over here is an example of the command that would be used. Insert into album description these values for the fields that are in that particular table or that database. We have a join, which is a select on 2 or more tables. Okay. So if I wanted to get your personal information as a student in my class, I would take my student database and I would take my course database. I would select based on yours, and from my student table, I would bring your personal information like your first name and your last name, and then your student ID would come from probably your student table, and then the course information would come from the course table. So that would be a select based on joining 2 or more tables. A select is just that. I'm asking for a subset of information from my tables. And then I can update or change data. This is what it looks like for us to understand, because if you were working inside the database, it would look like this, just like a spreadsheet. So what we do is we use a form-based interface, user interface. You fill out this form, client software converts it into an SQL and talks to the database. So in this case, we're searching for all records where the artist equals Beatles and format equals LP. So select album from albums where artist equals LP or Beatles and the format equals LP. So it would look for these 2 conditions on every record and bring back a subset of from that table of only the records that met this criteria. When we insert, we do the same thing. We use a form, okay? And then it's converted into an SQL statement. So when we add records, we're doing insert command. We have to tell it what table, the fields of information, and what we want those fields of information, what the values are we want replaced in those fields of information. So this is a little bit of a misnomer because when you insert a record into a table, it's typically what we call appended to the last record. They may be sorted, but when you first initially do it, it's typically appended to the bottom of the table. So this is what it looks like. We use a form to make it easier for us. It's converted into an SQL, and then the impact is on the table. So column intersects a row, a group of fields, which is information about a subject or an item or a thing, is called a record. And a group of records then is called a table. If we didn't have these 4 records or 5 records here, this would be a record type. These records that have data would be a record occurrence. Any questions? Send me an email. Thanks, guys.